Okay, today we're getting into Unit 4 Climate Dynamics. First, we got to talk about the difference between weather and climate. The big thing here is time. Weather is over a short period of time, is basically what you get on a given day. So if you say today is a hot day with thunderstorms or a 0% chance of rain, it's kind of your observational thing at that point in time. Whereas climate, on the other hand, is over a long period of time. How it behaves, because you are factoring in over 30 years more of evidence and information. So it's what you expect because we are basing it off of patterns as a result. So time is your biggest thing when it comes to weather versus climate. So what factors influence climate? Incoming solar energy, so basically sunlight, rotation of the earth, patterns of wind and water movement, altitude, and any type of surface features that could potentially manipulate what the pattern of climate is going to be over time. Our first LEQ we're going to talk about is what factors affect the heating of the earth. First, we have to talk about the 4 layers of the atmosphere. The bottom layer is called the troposphere. This is where our climate and weather are located, as well as our greenhouse gases. Since we have a lot of means, whether they be natural or human activity, release your methane, your water vapor, your carbon dioxide, and your nitrous oxide that help warm our earth. Air is the most dense, so we have the most air pressure in this layer, and then it is going to decrease with altitude. So think about as you go to higher elevations, the air pressure decreases. We'll think of this on a much larger scale when you go up a few miles from the surface of the earth. We're also getting colder with altitude. The air primarily is going to be nitrogen-based, as well as oxygen, and then a little bit of other gases. The second layer closest to the earth is called the stratosphere. This is where your protective ozone layer is. The ozone absorbs UV radiation from the sun. Because of this, it gets warmer with altitude instead of colder. It just gets warmer as you go higher. Third one is the mesosphere. This is where meteors burn up. This is why meteors don't really strike the earth and create craters like the moon. Based off of just the ice that forms in this layer, the meteors with impact and friction cause them to basically break down and combust. And you see this when you see your shooting stars. So arguably our coldest layer. And then we finally have the thermosphere, the top layer of the atmosphere. This gets warmer because of the proximity to the sun. This is where your auroras are, like your northern lights, the aurora borealis. And this is where your satellites are orbiting the earth. So looking at some differences, kind of what gets colder. Looking at this graph, we see it decrease in the troposphere, and we see it decrease in the mesosphere, and we see it increase in the stratosphere because of the ozone, and increase in the thermosphere because of the proximity to the sun. From a density standpoint, we increase going down. So troposphere has the highest pressure, thermosphere has the lowest pressure. Why is this the case? Because gravity is pulling everything down. So close to the surface, highest amount of pressure, densest air. This leads us to water currents. What affects the way that water circulates? Well, the unevenness of the earth by the sun. There is more heat at the equator and less at the poles. This also is due to the earth's tilt on its axis, and we also factor in the physical properties of air, water, and land. So the equator is hotter. This leads to hotter water. And what ends up happening is the warm, salty water, your surface currents, warm, less salty water will rise. So think warm air rises, well, warm water rises. And less dense water will rise with it. Whereas your cold salty water sinks. And that's kind of how we get it warms up, and as it gets further away, it cools down, sinks, and then comes back and surface and whatnot. So as you get close to the equator, you have a lot of warm surface water as a result. So the differences in temperature and salt, along with the wind currents, cause the movement of these ocean currents. And that's what kind of makes these countries around the equator very warm as a result, because water is a huge regulator of temperature. Deep ocean currents. In addition to surface currents, we have deep ones. So what the deep currents are is they go up and down the ocean and circulate in 1,000 years and affect heat movement. This is known as the Great Ocean Conveyor Belt, and this is responsible for heat transfer around the globe. You also may hear it termed thermohaline circulation, a little bit more of a scientific term. Thermo means heat, haline means salt. So you're talking about the temperature of salt water being circulated. So, warm surface flow, kind of moving around, and then it drops down and gets deeper. Cold water kind of goes the whole way around. And like we said, it is like a conveyor belt. So what this actually does is it kind of changes up the science a little bit. Typically, countries that are in the same latitude have the same temperature. Well, this kind of throws a wrench into that system. Because of the conveyor belt, and you have a lot of warm surface water going up past Europe right here, you're going to see a lot more warmer temperature in Norway than you are over here where the cold water is being taken than in Canada. So between Norway and Manitoba, Canada, you are going to see an average difference of an increase of 20 degrees Fahrenheit warmer in Norway than you are Canada. So a lot of your European nations, which have similar latitudes to Canada, don't really see the Canadian biomes, the taiga, that you see in Europe. And this is due to the Great Ocean Conveyor Belt or the thermohaline circulation. So the effect of the ocean currents, kind of other currents, the Alaskan current, as it moves from Alaska south toward California. This is why California is known for being cool and foggy during the summer. The Gulf Stream, which you may have heard about, carries water from the Caribbean north past Canada to northern Europe. And just another example of kind of that conveyor belt, how it causes the countries to be warmer than they're supposed to. The latitudes are supposed to match up and cause similar biomes, but between ocean currents and wind currents, that can change things up a little bit. The Gulf Stream helps warm up Europe and make it much warmer than it actually should be from a latitude sense. So with the Gulf Stream, scientists suggest that the melting of the Greenland ice sheet, which contains 10% of the globe's glacial ice, could cause this circulation to break down. So when we look at Greenland, which is right here, has 10% of the globe's glacial ice. So why would it throw a wrench into that thermohaline circulation? Is essentially what's going to happen is it'll cut off areas of the ocean from heat. So it's basically going to essentially stop the conveyor belt. So if that's not happening, where you're having ice melting and that's cooling everything down, then Europe is going to get cold. Much colder. We talked about, Norway is about 20 degrees warmer than it should be. If it is not getting that warm water, it's going to lose that kind of advantage it gets from the conveyor belt. It's going to start mimicking, potentially what Canada has in terms of its climate. As far as wind currents, we deal with convection, which we've kind of talked about already with the ocean. Warm air rises, cold air sinks. Similar to water, warm water rises, cold water sinks. Same general idea here. We have convection cells that move the heat and moisture between the latitudes. Essentially, we're dealing with the water cycle here. It's closer to the surface. The air is warm, so it wants to rise. As it rises, it is getting colder, so it cools down. As it cools down, it condenses into clouds, and when the clouds get too heavy, it precipitates down, and we have it continue. Tropical areas receive the most precipitation because they receive the most direct energy from the sun. Because what ends up happening is there is more solar energy hitting the equator. So what that creates is a lot of low pressure zones. As a result. Prevailing winds, these make up your convection cells, kind of your cells of air movement. We have many types: polar easterlies, northern easterlies, northeast trade winds, southeast trade winds, southern westerlies, polar easterlies. The key things here is we do have a circulation of 30 degrees. Now, why do they curve? Why don't they simply just go straight up and down? It is because of the Earth rotation, which we'll talk about here in a second. And we're going to call this the Coriolis effect as a result. What the Coriolis effect is essentially the Earth rotates on its axis faster at the equator than it does at the poles. This causes a curvature of the winds, as instead of the winds moving directly north, they move a little bit to the right. Instead of them moving directly to the south, they move a little bit to the left. And that creates the movements that we see with your prevailing winds that help push our ocean currents and essentially warm different parts of the world more than others. The albedo effect, what we have here is the percentage of solar radiation that is reflected from a surface. So in the middle of summer, you probably wear more light-colored clothes because the sunlight is reflecting off your clothes. Darker colors are going to absorb that heat and make you hotter. Same general premise here is sunlight that is falling to a lighter surface has a much greater reflection off that surface in comparison to how much is being absorbed. Sunlight falling to a darker surface, a lot more is being absorbed in comparison to what is being reflected as a result. So if more is being absorbed, temperature goes up. If more is being reflected, temperature stays down. So your ice sheets are good regulators of surface temperature. But the issue is with ice caps melting due to increased greenhouse gas emissions, the glaciers are retreating. And when the glaciers retreat, this is causing the oceans to widen, which means we have more darker color than we should. What will this do to the amount of solar energy that will be absorbed and turned into heat? Well, if we go back, as the ice melts, the glaciers are becoming smaller. And what ends up happening is the ocean is becoming bigger. Well, if you have more dark space, you have the temperature increasing as a result in comparison to simply being reflected and cooling the surface. So the surface temperature is increasing, and what's going to end up happening is it is going to make the ice melt faster, which will also have an impact on increasing the surface temperature. So we have kind of huge domino effect or cause effect relationship with, if you have more being absorbed, you have the surface temperature increasing, which makes ice melt faster. And if ice is melting faster, that's also going to increase the surface temperature since it's not being regulated as well. And this is one of our feedback loops, and this is one of the concerns with the polar ice caps melting and glaciers starting to retreat. Okay, that marks the end of the first lecture, a little bit of a longer one. Thanks for watching. Let me know if you have any questions.